Hi everyone, welcome to my new video on the new method to balancing chemical equations. And so today I would like to show you a new method that you probably have not used in your high school classes, Introduction to Chemistry class, in order to learn how to balance chemical equations. So up until now, we've probably learned this probably most common way to balance chemical equations. So for example, if we had, say, water, where hydrogen and oxygen combine to make water, then we're typically taught that there's H's and O's, right? There's two H's here, there's two O's here, and on the right side, there's two H's but one O. Then typically, we're taught that we need to balance these two on both sides. So in this case, we multiply this by 2, so it's 2, and that 2 and 2 match, so we need to multiply this by a 2. But then, the right side has now 4 H's because 2 times 2 is 4. But then now this side and that side are not balanced, so in order to balance it again, we add a 2 here, or multiply by 2, so 2 times 2 is 4. So 4, 4, and 2, 2, perfectly balanced. So this is our balanced chemical equation. Right, so we're just taught that you just need to make the left and the right balanced, and then you just like add coefficients in each part, and then you keep guessing and checking until you get to the right answer. Now, however, this works for a simple reaction, but sometimes it's not obvious which element should we start balancing, and sometimes if our process doesn't start out right in any way, then it can often get to wrong, and we need to use a bunch of trial and error, and that can get pretty frustrating. And so today I'm going to show you a really mathematical way, which is actually quite simple for its complexity, and in that way we can balance any chemical equation without having to guess where to start and where to end. So let's try this. So as an example, consider this chemical equation. So it is a combustion of heptane, and combined with sufficient oxygen, it creates carbon dioxide and water. And our task is to figure out the coefficients in front. Call these coefficients in front A, B, C, and D, where these are integers. Notice that under the law of the conservation of mass, we know that mass cannot be created nor destroyed, which means that the number of elements in the beginning has to equal the number of elements on the right. There are 7A carbons. And this is because every heptane molecule has 7 carbons, but we're multiplying it by A, so hence we get 7A. And on the right-hand side, we see that there's C carbons, because this is the only place where carbon is even located. Good. All right, and then for H, we have 16 times A. And now on the after side, we see that there's 2D H's. And then for O's, we can see that here there are 2 times BO's, and then on the right hand side we see that there's 2 times C, but then there's also an oxygen here, so then it's plus D times 1. Now let's break this down into two methods. The first method is actually a simpler method, but can be a little bit messy. Whereas the second method requires the knowledge of linear algebra, but in exchange, it's a lot more organized. So I'll show you what I mean. Let's do this first method very briefly. So really the first method, I would say, is kind of like a series of substitutions and solving basic equations, and then you're just simplifying it. So choose a variable that you want. In this case, let's just choose D. It could be any A, B, C, D. Doesn't matter. But once you pick it, just be consistent. Alright, so if you look at the first, second, and third equation, well, if you look at the second one, you can see that if you divide by 16 on both sides, then A is 2 over 16D, which implies that A is D over 8. So great, we already got our first equation where A is in terms of D. Alright, cool. And we know that from the first equation, that 7A is equal to C. Plug this A in there, and hence we get 7 times D divided by 8 equals C, which implies that C is equal to 7D over 8. Nice, now we got our second equation, where C is in terms of D again. And now all that's left is now that we just solve for the last equation. So let me write this here. So this is from equation 2, this is from equation 1, and now we're down to equation 3, where 2B equals 2C plus D. We don't know what B is, but we do know C. C is 7D over 8, so it's 2 times 7D over 8 plus D, where this simplifies to 7D over 4 plus D, which is 11D over 4. And we know this is 2B, so 2B equals 11D over 4. And dividing by equals 11D over 8. And therefore, now we have a whole set of equations that are all in terms of D. So if I were to rewrite this,
A equals D over 8, B equals 11D over 8, C equals 7D over 8, and of course D is equal to D, which is pretty trivial.
Alright, and now we have our solution. Almost though. Now we just need to set D as a number, and then we can set A, B, C, D as our final answer. So if you look at the answers here, we notice that our biggest common denominator is a 8. So why not just choose D to be 8, so that way A, B, and C are all integers. So if D is 8, then we let A equal 1, right? Because 8 divided by 8 is 1. B is equal to 11, and C is equal to 7. And therefore, since we know A, B, and C, D are coefficients in front of this chemical equation, C7H16 plus 11O2, which yields 7CO2 plus 8H2O. And that is our final answer. Great. Alright, so this is basically how the first method works. As you can see earlier, it was really just a series of substituting and simplifying equations and making it in terms of only one variable, as I've shown you here. Alright, now here's our second method. Our second method is where we will start off from here. So I will write them down again just for convenience. Alright, cool. So now we know that this is really just a system of equations. So first, what I'm going to do is subtract every term to the other side. And hence, we get alright, cool. And then notice that this is really just a system of equations, so we could set this into a series of matrices where 7, 0, minus 1, 0, 16, 0, 0, minus 2, and 0, 2, minus 2, minus 1. And if you multiply that by A, B, C, D, then we get 0, 0, 0. Yeah, and notice that we're really just solving for this by using the Gaussian-Jordan elimination. And so if we solve this Gaussian-Jordan elimination, then we actually just end up getting, right, which implies that A is 1/8 D, B is 11 over 8D, right, yeah, 7 over 8, and yeah, and it matches exactly as what we get here above. And hence, we can make the same conclusion that if D is equal to 8, which is the smallest common denominator out of A, B, and C, then we can make the same conclusion that A is 1, B is 11, and C is 7, and hence we get C7H16 plus 11O2 yields 7CO2 plus 8H2O, and hence we are done. And also, in the link in the description of this video, I include a reference to another YouTube channel that talks about that shows how to solve for the reduced row echelon form of a matrix. And remember that we had to solve for the reduced row echelon form of this matrices. So please take a look at Lena's YouTube channel so that way you can kind of see how to solve it for yourself. All right. Anyway, that's it for today, and thank you for all watching for this video. And I hope that this was pretty interesting in learning how to solve for chemical equations in a very mathematical sense, but with no trial and error or any sort of guessing needed. Alright everyone, have a nice day. Bye!